So today is lesson 11. We're getting to the end of fall, getting into the winter weather here in central Ontario. All right, let's dive in. So what are we doing today? Today is the first of our two classes where we're going to look at doing unit testing in ASP.NET. Now, I know we've kind of got a split. We've got two different groups of students in the class. Some of you are in computer programming. Morning, Colton. Morning, David. And if you're in computer programming, you have had a little bit of exposure to unit testing with Java using JUnit. If you're in the web program, unit testing is probably something you have not seen or done before. So we will sort of start from the beginning in .NET. Again, if you're in programming, it may look a little bit familiar to what you've already done in one of your Java courses. So we're going to start today by having a look at assignment 4, which is due in a couple of weeks. And then in today's class, we're going to kind of do an intro and do some basic unit testing. And that's going to give you some of what you need to complete the assignment. And the rest of what you need, we're actually going to do in class as a lab next week. So you'll be able to get started on assignment 4 if you want, but you probably won't be able to complete it until after next week's class. So assignment 4 is now available on Blackboard, and we'll go over the instructions and requirements. So for this assignment, you're going to be setting up and implementing unit testing in the web application that you have been creating in assignments 1 to 3. Okay, so you don't have to make a new project. You're going to continue to work with your existing project. It counts for 10% of your grade, and it will be due 2 weeks from yesterday at 5 o'clock on Wednesday, December the 8th. To submit, all you need to do is give me the same GitHub link. Your site does not have to run on Azure or Smarter ASP, so I don't need that because I'm not actually testing the web application. I'm testing your unit tests. So those happen inside of Visual Studio. So I just need your Git repository. I will have to download everyone's project and run it locally in order to mark it. Okay, so you do not have to worry about the web server deployment this time at all. Okay. The unit testing that we do in class this week and next week, it's there as a reference. The point of the assignment is not a copy, paste, find and replace exercise. I do actually want you to write the unit tests using the stuff we do together in class as a guide. So within your existing solution, you're going to create a new project, a unit testing project. So your solution that currently holds your one web project, it's now going to hold a second project for unit testing. And we will do this in class today with our pet store. You then need to create a test class for one of the controllers in your project. So if I think of, for example, Chris's project, Chris, correct me if I'm wrong, but I think you've got a species controller and an orders controller. Is that right? Or just to put it in context, if I think about somebody else's morning, Tushar, somebody did a hockey site. Can't remember who did a hockey project where you had teams and players. Whose assignment was building a hockey site? Okay, yeah, Colton did the tournament site, right? So Colton, did you have like a bracket and players, something like that? Those are your controllers? Okay, so for the project, you will need to unit test only one of the controllers. You don't need to write all the unit tests for brackets and then all the unit tests for players. You just pick one of the two. Okay? So you are going to write unit tests for one of the following methods in one of your controllers. Okay, so the assignment's not that long. You're also going to use an in-memory database to create some mock data. So 3 records will be sufficient for this. And you'll write a separate unit test for each outcome that can occur in the method you choose. And this will become a little more clear as we work through today's lesson. Okay? So for each one of these methods, typically there are somewhere between 3 and 5 different outcomes that could happen when we call the method. So when we're writing unit tests, you'll need one test for each outcome. And you'll get to pick which of these methods you unit test. You don't have to do all of them. So today in class, in our pet store, we're going to write unit tests for the index method and the details method of our pets controller. Next week in class, you're going to have an in-class lab as a group where each group is going to be assigned 1 or 2 methods, and you're going to write the unit tests that those methods will require. And then I will kind of collate all of that sample code together, which will help you to finish assignment 4. There's a few hints here, and I'll come back to these later. They'll make more sense once we actually start doing some of the testing in our project for today. And you only need to make 2 commits. I don't care about the dates. They don't have to be spread over different dates. Just want to see 2 commits in your Git repository. Okay, so the grading, couple marks for setting up your unit test project and your mock data successfully. 8 marks for doing the unit tests. So again, one test per outcome in one method in one controller. And then 1 mark for using Git appropriately. Okay. Does anybody have any questions? Okay. I'll probably come back and refer to some of the assignment requirements as we're doing the lesson, because there are a few things in here that will make a little more sense once we actually start working with this. If you are watching the video, this video, because you did not attend the class live, I will strongly encourage you to go through all the lesson work we're going to do this week and next week. It's going to be very difficult to complete the assignment if you don't do that. So give you a minute. If you look at the lesson 11 folder, or I'm sharing my screen, we're going to read this quote from Scott Guthrie, who's a very prominent .NET developer, worked for Microsoft for I think a couple decades now, describing what unit testing is and giving context of why we might use it. So I'll give you a minute to read this. So as a follow-up to this gives you some context of why we would unit test. For those of you who are in the computer programming stream and you've done a little bit of unit testing before with JUnit, is there anything you can tell the rest of us in the chat about what unit testing is or how it works? Is there anything you remember about it that would be useful for those of us who've never done unit testing before to know? Okay, well, let's take a look at unit testing a little more carefully. So a unit test, okay, thanks Tushar, it's creating some sample data to check that every scenario is working properly and it can give an error. Okay. Thanks Tushar, it can give an error when it's required. So our unit tests, are we testing, like, what's the scope of them? Are they testing at like a large scope, a medium scope, or a small scope? Like one unit test. Yeah, it's very small. So the idea is most unit tests are actually testing a specific function or method. And then we want to test, and also within a test, we're typically testing one piece of behavior. Okay. So what do we mean by one piece of behavior? Well, why don't we open up our pet store project and let's take a look about what this actually means. Yeah, thanks, Ralph. Virtually the smallest piece of code that we can logically isolate in a system. That's a good definition. So it's at a very, very granular level. So unit tests are not large, but we typically will have a lot of them. So I'm going to close all my files here. Close everything. And we're primarily going to focus on our pets controller for today. So in here, we've got 200 lines of code, and we've got something like, 8 or 10 different methods. So roughly, just as a guess, if we were going to unit test fully this project, roughly how many unit tests do you think we might need? If we've got, we can see the number of methods here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 11 methods in here. So if we're unit testing one method at a time, and then we're also unit testing each potential outcome of each method, we've got 11 methods. Roughly how many unit tests do you think we might need to test every single thing in this controller? You can take a guess. Okay, Ralph says we might need 11. I would suggest we'll need at least that, Ralph. Any other guesses? Do you agree with Ralph? Will we need less? Will we need more? Well, I'm saying we might need more. I only will need less. Any other opinions? If you had to ballpark how many unit tests we would need. Okay, one for each new change we implement, could be. But let's look at our details method for a minute. How many different outcomes are there in this method? when we call the details method, how many execution paths could our code take? Okay, Tushar says 2. Other opinions? Do you agree with Tushar? Are there 2 execution paths? Are there less? Are there more? Raymond says 3. Okay, Ralph says 3. I would tend to agree. I actually see 3 different paths. So what are the 3 different scenarios here when we call the details method? What would those 3 paths be? Yeah. Okay, so the first scenario here is we call details. Right. That's the first one. That's right, Ralph. So if we have no ID, we get not found. That's right, Raymond. Our second one is we have an ID, but that ID doesn't, when we use it to query the database, the object that comes back is null. So we have somebody puts in like pet slash detail slash 1 million. If we don't have that pet ID, again, that's a different scenario. It's the same result, but it's a different scenario. And then the third scenario is we have an ID, and when we use it to run our query, we actually find a match in the database, and we want to send that, load the view and display that pet. So if we run it in the browser, let's actually run through all 3 of these scenarios in the browser. I could go to /pet/details 3. Oh, I guess I have to log in because that's an admin function. So this is scenario 1. I have a valid ID. Sorry, this is scenario 3, really. I have a valid ID. It displays the view and shows information about the pet. Second scenario is I have an ID, but there's no match. Now, right now we get a blank screen. So this is part of where our unit testing actually points to a flaw in our program, right? If I go and look at my console, in my network, when I run it with an ID that's invalid, I get a 404 response, which is here. For this not found method returns a 404. But this is not really from a usability point of view, this is not an ideal response. What should we see in the browser instead? Showing the user a blank screen is not helpful, right? Because they don't know that this pet doesn't exist. They might just think the page crashed. There's an error. So we should, by testing it, we can see this response we get is kind of inadequate. What should happen here instead when we put in an ID that isn't valid? What should we show to our users? Okay, yeah, we could redirect, potentially. Morning, Preston. Redirect where? We have a few options. On most sites, if you request a resource that doesn't exist, what do you typically see when you generate this 404 response? How can we indicate to the user that the resource they're asking for doesn't exist? Yeah, probably an error page, I think, David, would make sense, right? So we actually have a default error page here already. So we could redirect them here. Or I think what we'll do is we'll make typically most sites have an actual 404 page. Right, if we try to go to one, I don't know, we'll just go here. Is that, let's see, right? We get some kind of 404 handler. So if we have an invalid ID, you shouldn't just give a user a white page. Let's redirect them to something that says we can't find it. And now let's try the other scenario, first scenario, which is we have no ID at all, right? Same thing. We're calling details, but you can't call details without a valid ID. So again, we get this 404 response. So by thinking about unit testing this, it reveals kind of the inadequacy of the scaffolded code. It works fine down here when we have a valid ID, but our application doesn't really behave properly in either of these two scenarios. Okay, so we've got three scenarios: no ID, an invalid ID, and a valid ID. So to properly test this method, how many unit tests do we need? I'll ask that question again. So we had some suggestions. We might need 2 tests. We might need 3 tests. So now that we've kind of talked this through, how many tests do you think we need? Do we need 2? Do we need 3? Do we need more? So use the chat again. Tell me how many tests do you think we're going to write for the details method, which we will actually do today. Okay, so Tushar saying, can we do 1 because 404 is the same, or 2? Well, these are different conditions. So we've got the same result, but the condition is different. So with unit testing, each condition we want to test should have its own test. So I would suggest we're going to write at least 3 unit tests here. 1 where we call the details method but don't pass an ID. We want to ensure we'll get a 404 error. Then we want to pass an ID that doesn't exist in the database, and then we also are going to want to ensure we get 404 response then as well. I'm actually going to suggest we're going to write 2 tests with a valid ID. The first test is going to check that we get back the matching record from the database. We might want to write a separate test to also ensure that the correct page loads, that we are actually loading the view called details. So we're probably going to write 4 tests for this method. So that's 1 method, we're going to have 4 tests. We said we've got 11 methods in the project, in the controller. So if we were going to fully unit test this controller, we'd probably need somewhere in the neighborhood of, 30 some odd tests. And we're not going to do 30 tests today. I think we should write about 9 or 10 in total. So the benefit of writing those tests and saving them in Visual Studio is not only does it point out problems in our code, but it also means those tests are saved permanently. So when we make changes, as Raymond was talking about, if we make changes later, we can run all our old tests to make sure that we haven't broken any of the logic or any of the functionality that was working previously. So it's about ensuring it's about performing ongoing quality assurance. So we're focusing on unit testing in this course. There are some other kinds of testing. right? So if our unit tests are at a small, really granular level, what other kinds of testing might we do? Probably beyond the scope of our course, but there's probably 3 or 4 other types of tests. Can you think of what other kinds of testing we might want to do before we make an application live? Besides just unit testing? What other kinds of quality assurance checks? Should we do? I want you to think about this from a client perspective. Let's say you hired me to build a web application for your business, and you invested a lot of money in this. Okay, so what kinds of testing would you want me to show you before I say, okay, the site's ready, the site's live now, here's your final invoice? Okay, manual testing. Okay, Tushar, can you be more specific? What kinds of things would you want to manually test? Let's say you're investing $100,000 in this web application. Okay, so you would want to test all the functionality in your browser, yes? Okay, for sure, Chris, you would definitely want to do that. So the buying, so that really has to do with, right, we've got our third-party payment service. So we don't write the code, we just are working, we're connecting to our payment service. So that particular kind of testing has a specific name. So we're testing our application with an external component. Yeah, so all the APIs, right? Like the Google API, we've got the Stripe API. Does anybody know what that's called when we're testing our application that we built with any of the APIs or components or services that are external, but that have to work with it? And that would include our database, the Tushar you mentioned as well. So that kind of testing has a specific name. It's almost the opposite end from unit testing, right? Unit testing is very small, one method, one outcome. It starts with an I, that kind of testing that you're all referring to for things like the payments, the database, the APIs. Thank you. You got it, Ralph. So that would be integration testing. So it's almost at the opposite end of the spectrum from unit testing. Right? Unit testing is very small. So integration testing is how does the application work with all of the external services and components? So, and the database is an external component, right? It doesn't live inside our Visual Studio project. So this means when we're unit testing, we have to remove the database component for the unit test. We're just testing our application logic. So we're going to need some kind of way to run our web application without connecting to SQL Server for unit testing. So yeah, we would do integration testing. Some of the other forms of testing, we might have user acceptance testing. So I think, Tushar, maybe that's what you were talking about in the manually testing part. We might also do things like performance and load testing. So how is our speed? And load testing allows us, we use some software tools, so it can do things like make thousands and thousands of simultaneous requests to the server, and we can see how it performs. Can it handle a large volume of users at one time? And it's important we do those kinds of tests because just because our application runs fine when one person's using it doesn't mean it's going to run fine if we've got hundreds or thousands or tens of thousands of users doing things at the same time. So to perform proper quality assurance, we're going to do all those things. We're going to do user acceptance testing, we're going to do integration testing, we're going to do load and performance testing, and we're going to do unit testing. We're going to do all of them. So if you think about, well, you're paying me the $100,000 and you're saying, okay, when is my application going to be ready? That's got to be part of that life cycle. It's not just I build it, I go, okay, it compiles, it runs fine in the browser, here you go. Right? We need to perform all these kinds of tests. So we're going to really focus in, though, for now, for our purposes in this class, we're going to focus in on the unit testing piece of it. So what we'll do, we're going to implement unit testing in our pet store. I've adapted it from this old tutorial series from Visual Studio Magazine, and they actually talk about test-driven development, which we're not going to do, but it's a term you should be aware of. In test-driven development, we actually work backwards. Before we write any code, we actually write all the unit tests. So we figure out what are all of the things our application should do and what are all the possible outcomes of every function or method. And we actually write the tests first, and then we write the code to match the tests. So it's kind of a reverse engineering rather than writing our code first and then testing it. And this is a proven methodology that has a lot of benefits in terms of writing good code that works well and is reliable. So let's start to play around with unit testing. So we're going to come back to our pets controller in a little while. I just wanted to provide a bit of an overview, a little bit of context of where this is going. We're going to create a new, first of all, a really simple controller and just do some really basic unit tests first, because our pets controller is a little more advanced. So I don't want to dive right in there. I want to look at the mechanics of unit testing in a little bit of a simpler context first. So in our project, I'm going to right-click my controllers, and I'm going to add a controller. It's going to be an empty controller. And I will call it dummies controller. The name isn't even really important. So it just gives us a very simple controller with an index method here. All this index method does is load a view. If we try to call this in our browser, what'll happen if I go to localhost/dummies? What's going to happen right now? So I haven't written any code. I just used the Visual Studio wizard. Right, we've seen this error before. How do I fix this? Yeah, we can just create the index view thanks to Sharp. So I'll just right-click my method name. I'll choose add view. Yep, thanks, Ralph. We'll just add an empty view. We'll accept the default name as index because that matches our method name. I'm not going to make any changes here. I'll just click add. And we can just put on some text. This is just a dummy page for unit testing. Okay, so once we add the view, doesn't matter what content goes on there. Right, so now it loads at localhost/dummies. Okay, so I haven't really done anything new here. But now let's unit test this. So right now our method, it only does one thing. There's only one possible path. So if we wanted to test that this method behaves, what would be our success criteria? What do we expect to have happen when this method gets called? So all unit tests are designed as a simple pass-fail. We set up what we expect to happen, and then we evaluate. Yeah, thanks. That's right, David. Really simple. The index view gets loaded. I mean, we're in week 11 of working with MVC, so that should be self-evident. But thank you, David. That's exactly the answer I was looking for. So let's go and set up our unit testing project, and you'll have to set up a similar project in your assignment 4, where we can then call this method and check whether it behaves as we intended. So let's go to our Solution Explorer. And you notice up at the top, it says one of one project. Right now, we have only one project here, which is our web project. I'm going to right-click my solution. I'm now going to add a new project. It brings up all the project templates. So far, we've only been working with these .NET Core web apps. Up here in the you can either use the search box, or if you change these filters, it should say we want C# as the language. And in the project type, it defaults to all project types. If you change that to test, it hides all of the projects except for the unit testing project. And there's a few different unit testing frameworks. There's 3 big ones. There's one called MS Test. This is the one we're going to use. A project that contains MS Test unit tests that can run on .NET Core on any operating system. There's 2 competing products. So this template is created by Microsoft. There's other unit testing frameworks called NUnit and XUnit. They're all similar, but we're going to use MS Test because it's the simplest and it has the best integration in Visual Studio. All the tools are already included. So I'm just going to pick this MS Test project. And again, I got here just by filtering the project types. I just filtered the project types for test projects only, and I changed the languages from all languages to C#. And then I'll just click Next. I'm going to call my test project positive tests. So the same name as our solution and web project, just with the suffix of tests.
Excuse me, so you're gonna like right-click positive or pets world and then add new project, or you just press file, add new project.
I'll show you again. So at the very top item where it says solution, positive pets 1 of 1. I'm going to right-click that item, and then I'll choose Add New Project.
Got it.
Okay. And then in the Add New Project window, you can filter the language to C#. And in the project types over here, you can just pick Test.
Got it.
And then we want to pick that first item that should show up, which is MS Test project. So let's click on that. And I'm just going to add the word tests at the end of the project name. And click Next. It will default to our current .NET framework of 5.0, which is good. I'll just click Create. So now if our solution says 2 of 2 projects, and down at the bottom, we can see we now have our unit testing project. And it's got a class here called Unit Test 1. So it looks kind of like our other classes, except it has this test class annotation. So this tells us that this class contains unit tests. It's not application code, it's for testing purposes. And then we have one method here, and it has this test method, which again also means this is a unit test that we can execute, and Visual Studio will tell us whether the test passes or fails. Now, I'm going to change the name of my class. It defaults to Unit Test 1, which I could leave, but I'm just going to right-click and rename it. And I'm going to call it Dummies Controller tests. And then it asks me if I want to also rename any references in code. I'll just say yes. That's not an essential step, but by convention, if this class, if its purpose is to unit test this class, they'll have the same name, and this one will just have the suffix again of tests. We can use this first unit test that's here, but I'm going to rename it. Normally, when we write unit tests, we want to give them descriptive names. So typically what the names do is we describe which method are we testing and which scenario or which outcome is the test going to simulate. So again, if we look back at our details, we might have 3 tests that start with the word details, but we might call them something like details no ID, details invalid ID, details valid ID. So the test name, the unit test will include the method name we're testing and the name of the scenario. So we'll call this one index loads view. Now, the pattern, all unit tests, and it doesn't matter if we're in .NET, if we're in Java, or which framework you're using, they all have the same basic structure. And the structure of unit testing, there's 3 steps. We've got arrange, act, and assert. So what do these mean? Arrange is set up any objects, variables needed, call the method we want to test, and set up the right conditions. The act is execute the method and retrieve the result. And then the assert is check if the result is as expected. So this is the basic pattern. Set things up, run the method, and then evaluate. What was our response? So we'll write kind of 2 versions of this test. We'll write it very simply, and then we're going to need to improve it. So in our arrange, and sometimes we need the arrange part of the process, other times we don't. So we want to call the index method we just built and check what comes back. So we'll do a really simple version first. We do need to arrange something here. In order to call this method, we'll need one object. We don't need any variables, but we need one object. What object do we have to create in our setup in order for us to test that index method? Remember, our test is in a different file altogether from the file that contains the method we want to test. So what object would we need to create here? We want to test this method. Where does this method live? In what object? In what class? Yeah, we need an instance of our dummies controller, right? So we have to, in our arrange, controller equals new. Right? We need to instantiate an instance of this class before we can call that method. And when we do, we get our infamous red squiggly. Doesn't know what the dummies controller is. Well, there's a good reason for this, right? These are in different projects entirely. They're inside of different DLLs. So right now our unit testing class, it can't see this class. So what we need to do, it wants us to add a reference first from the unit test project to the web project, and then import the controller's namespace. So this is what this code hint at the bottom is asking us to do. So when I add that reference, first I'll see in Solution Explorer, inside the dependencies of my unit test project, my unit testing project is now making a reference to the web project. So we can then import namespaces, and it also adds a reference to the controller. So now my object reference is valid. Now that we have an instance of our controller, we can call the index method. Let's say var result equals controller dot. And now I can see the index method. So we can now execute the index method that returns an iAction result, and it's being stored in a local variable. So now all we want to check for now, we just want to make sure that we got some result back, that our result isn't null. It's not a very good test. We're going to improve it after, but we're going to kind of do this in steps. So I can use the assert command. When I call dot, you can see some of the assertions we can make when we're checking results. We can check that two things are equal, which is what we'll use most of the time. We can check if something is true or false. Or for now, to make it really simple, we'll use the is not null method. Let's just check that we get something back out of the method. Again, it's not a very good unit test, because right now, if this method returns, a false or a JSON object, our result won't be null. So we'll improve this test, but we're just going to run it very simply for now. So I'll save my change, and now how do we actually run? There's a lot of different places within Visual Studio that we can actually try to execute the unit tests. The simplest place is to go to the Test menu and open up the Test Explorer window. And it tells us here, we have one total unit test, no passing tests, no failed tests, but we have one not run test. So one test that's been discovered, but it's never actually been tried. So if we click either run button here, it's now going to try our test, and it tells us that now we've got one passing test. And if I kind of open this, it shows me where the unit test is. And here our index view, when we loaded it, passes. Now we're going to see a bunch of other indicators. We get a green checkbox here now above the unit test saying, hey, the last time this test ran, it passed. If we make changes and we want to run it again, we can even run it right from here. I could just click my little checkbox and run it. There's another useful reference that this gives us as well. If I go back to the dummies controller, it now updates. It says I've got one reference, and there's one of one passing tests that call my method. So I have these little visual cues as we're writing our unit tests, whether our tests, how we're doing in terms of writing unit tests that are passing. So the goal is we want all our tests to pass. When we're writing our whole suite of unit tests, every one of them should pass. That all of our methods, all of the outcomes give us the result we are expecting to get. That's kind of the goal. As I said, this is not a great unit test. It's really just checking that we got something. It's not actually checking if we got the index view that we expect to get. we will rewrite this when we come back. We're about due for a break. We'll rewrite it so that we'll actually check specifically that we got the exact result we intended to get, rather than just, so we'll change, we're going to wind up changing this assert statement. Okay, I'm going to upload to GitHub, and we will take a break. But are there any questions before we take a break?